Good afternoon, everybody. I hope you're enjoying this hot, overcast, humid day, but now you will because it's time for organic chemistry with your host, me, Dr. White. All right, we're going to be doing a lot of important things that'll help you out for Thursday. Let me just remind you, and I sent out an update this Thursday at 1 p.m. I will send out the password for the final exam. And I will upload later today or sometime tomorrow morning the final exam. You'll download it, open it up, take it, and upload it to assignment area of D2L. Did I say Blackboard should be D2L? And uh, historically, when I'm face to face, most students are done within 90 minutes. I think I said take up to 3 hours. Uh, Either you know it or you don't. Hopefully, you won't be cheating. Please don't. I'll know. I have secret things in there I put in that help me identify that, and they work. But, anyways, uh, Thursday, there will be no Zoom meeting. Just I'll shoot out, email out the password. I guarantee by Sunday, 1 p.m. in D2L, I will have your final exam score, your total points for the semester, your percentage, and your grade. Now, when I put it in Access ECC, sometimes I'm not sure how often they refresh the database. That may take up to 24 hours or more. But the grade in D2L is your official grade. Now, one thing I don't do for a final, and I don't do it when I'm face to face, is I will not be sending back your individual points for each question. I just don't do that. But I will tell you, and I mentioned, I think, yesterday, that any student within 10, usually 10, but 15 points of a cutoff, I go back and regrade the whole final, not just part of it. I check it and double check it to make sure I can't bring you up to put you at a higher grade. Uh, I don't get paid by having students get lower grades or higher grades, but it makes me feel good, and I like to make me feel good to have students succeed. All right. Any questions on that so far? I've already talked about the points breakdown on the final. So let's get to work. What I'm going to do today and tomorrow is I'm going to go through a review of the whole semester. This helps students, at least that's what they tell me. And also, I know because I can see their final exam scores. And historically, the final exam average is somewhere around 170 to 180, give or take a few points. Remember, it's same as two tests, so that's same as a test average, about 85 to 90, which on a final is quite good. So let's get going. Leaving my, first of all, I should do this. Advice, important advice for the final exam. First of all, remember there's 4 bonds to carbon. 60 to 70% of things I mark wrong on a final. If a student had said, oh, I've got 3 bonds to carbon, I've got 5 bonds to carbon, that can't be right. They say, I've got to do something different. So check your structures, make sure all carbons have 4 bonds to it. Next, do you break carbon-carbon single bonds? No, except for combustion. You don't in my class. And in the real world, too, it's very rare. So you don't break carbon-carbon single bonds. And the final thing, which I've taught you, and I do all instinctively without even thinking, when you look at a molecule, look for what's different. What's not a carbon-carbon single bond, what's not carbon or hydrogen, is where the fun is. That's going to be a functional group, and that's where the action takes place. So whenever you look at a molecule, look for what's different, what's not a carbon-carbon single bond, and what's not carbon and hydrogen. Now, as I mentioned yesterday, the best way to prepare for the final exam is use your hourly exams as practice problems. Am I going to put the same problems on the final? No. But am I going to have similar ones? Of course. Look at my practice problems. They were similar to what was on the hourly exams. And that's why I call them practice problems. All right. Leaving my class, there are 4 things I expect you to know. Let's go through those. Everybody should see my whiteboard. The first thing you should know is how does soap work? First, you should know soap, structure, nonpolar tail, and a polar head. And water is polar, dirt and grease too, but I'll just talk, is nonpolar. And the whole key to the puzzle is like dissolves like. And if I have a piece of dirt on my hand, I magnify it. Water looks at dirt and says, oh, you're nonpolar, I'm polar, I know like dissolves like, I want no part of you. But the soap molecules you're also using, the nonpolar tail are attracted to the dirt and it totally surrounds it, but I'm just showing a couple. And you should know this is called a micelle. And now water looks at the micelle and says, oh, you're polar, I'm polar, because it only sees the polar heads surrounding the dirt. Let's go down the drain together. But the key of this is light dissolves light. And just now when I was washing my hands and also my dishes before I wash my hands, I was thinking, oh, I'm making micelles and that's how I clean my dishes. All right, next thing you should know. You should be able to describe with words and a general reaction what happens when you eat something with fat or oil in it. And what's the functional group in fat and oil? It's a triglyceride, and that's an ester. In your stomach, you have acid, water, so it's acid hydrolysis of an ester. Next, you should know what happens in your stomach when you eat a carbohydrate. And what's the functional group in a carbohydrate holding glucose molecules together? An acetal. And what happens? Again, in your stomach, acid and water, so it's acid hydrolysis of an acetal. And the reaction you learn for test number 2 acetal or ketal acid plus water. Keep your eye on the carbon with 2 oxygens. That becomes a carbonyl carbon. Remember, carbonyl, carbon double bond to oxygen. You got a ketone or aldehyde plus the alcohol you would have used to make that. And for those who must, you can put a 2 there. You don't have to. But I still remember the twins I had who got upset when I didn't do things like that. And the final thing in terms of food groups is you should be able to describe with words and a general reaction when you eat something with proteins in it. I don't know if you can have this one. Hey, go into a restaurant and say, can I have a protein to go? But anyways, look out, it's Bad Humor Tuesday. In your stomach is acid plus water. What's the functional group that holds amino acids together in a protein? And that's an amide. So this is acid hydrolysis of an amide. And the general reaction is an amide plus acid. Now, because I need a counter ion, in your stomach, there's hydrochloric acid, HCl, and water. And what do you get? You get back the carboxylic acid you would have used to make that amide, plus the amine salt of the amine you would have used to make that amide. And there you go. Those are four actually important things you should know leaving my class. Now, what I like to do, and it's worked over the years, I've always done this, I'm going to go back and do the reviews for each test, but I'm going to give you some practice problems too, which will help you out. All right, we started out long ago, beginning of summer. Boy, did summer go quick. Hydrocarbons. You should know hydrocarbons are molecules with only carbon and hydrogen atoms. And when we talk about hydrocarbons, there's two types. Saturated hydrocarbons. Since they're a hydrocarbon, it's a molecule with only carbon and hydrogen atoms. And, excuse me, the saturated says you only have carbon-carbon single bonds. Now, unsaturated hydrocarbons are molecules, hydrocarbons with only carbon and hydrogen atoms, and they have at least unsaturated, at least one carbon-carbon double or triple bond. Now, I didn't ask you to learn the names, the definition of an alkane or cycloalkane, but you learned how to draw them. And don't forget, there's 4 bonds to carbon. And I started talking about IUPAC, which I'll never ask, and that's International Union of Pure Applied Chemistry. I just think it's cool to say that, so I do. But anyways, when naming a compound, find the longest chain, name it as an alkane. Then use the alkyl groups, the alkane names 1 to 10, which you learn from this chart. 1 methane or butane, 7 heptane, octane. Did anybody happen to drive by a gas station and think gasoline contains a lot of alkanes in it? Well, it's my last chance to get that down in your brain. And 10 is decane. I taught you that if you have branching, we call those alkyl groups, which are not functional groups. I have them written here, but I have them looking nicer here. Let me do one thing. And the key alkyl groups are your good friend now, the methyl group, 2 carbons ethyl, 3 carbons at the end of a chain is N-propyl, middle isopropyl. For 4 carbons, there are 3 of them, but one that I haven't taught you, guess what? All the years I've been doing organic chemistry, I've never used. So that's why I don't teach it to you. If you have 4 carbons to the end, it's N-butyl. 3 carbons to center carbon to a ring or a chain is called tert-butyl. Which I also call T-butyl. Organic chemists are lazy. Now, I talked about cycloalkanes and alkanes. So let's have some fun. And why don't you give the IUPAC name for the following? Your turn. And let me check something. Hold on. Once in a while, when I do things on the fly, sorry about that. I'm going to have to change this. Last day, now I'm having there you go. Sorry about that, sports fans. Give the IUPAC name for that molecule. And when you're done, give me a thumbs up. You know the drill. All right, I think everybody's, I'll give you another 8.6 seconds. That's about 8.6. So what's the longest chain? Good question. Let's get counting. 1, 2, 3, 4, 5, 6, 7. You go this way, 6, 7, 8, 9, 10. And there's one other chain, actually 2, but 1. I'll check 1, 2, 3, 4, 5, 6, 7, 8. So the longest chain is 10. And that's decane. And when we say decane, that's all spoken for. Oh, look, your old friend, the methyl group, and 2 carbons ethyl. And the ethyl group is on carbon 5, and the methyl group is on carbon 2. Now, since I'm not holding you to the IUPAC alphabet rule, if you put down 2-methyl, 5-ethyl decane, that would be correct. Let's do another one. Go for it. What's the IUPAC name for this? I see people are finishing. Give me 1 second. There's something I need to do. All right, let's do this. And the question is, give the IUPAC name for the following. Oh, we've got a ring. How many carbons? Count the bens, there's 6, as cyclohexane. Now, common mistake on test 1 in the past and the final, people forget the cyclo. If you do that, I'll mark it wrong. Then I have an N-propyl and a T-butyl. I can call this 1, 2, 3, 4 for cyclohexane. Do not use ortho, meta, or para. That's only for benzene. So that'd be 1 T-butyl, 4 N-propyl, cyclohexane. Now, if you had gone 4 N-propyl, 1 T-butyl, and put the 4 N-propyl first, that's okay. If you have the number switch, I'll allow that, even though this is the right IUPAC. And if you have everything, the name and the number switch, I would accept that. All right, now, just to remind you, when you have a IUPAC name, you should know how to draw the structure. And why don't you try this one, draw the structure, 2,2-dimethyl hexane. All right, let's do, wait, I see people still working. If you're done, give me a thumbs up. Or people already gave me a thumbs up and it's done, so I'm gonna get going. How do you decode this? You start from the right and go left. Hexane, 6 carbons. On carbon 2 are not 1, but 2 methyl groups. And you know there's 4 bonds to carbon. And there you go. All right, let's get back. Now, in the real world, where do you find, I still haven't corrected it, alkanes and cycloalkanes in gasoline? Actually, that should be gasoline. Remember propane in your barbecue? Natural gas is an alkane. Vaseline and baby oil are alkanes. Would I ask on a test or a final, give an example of an alkane you use in your daily life? And the answer is yes, I did that in test one. Now, at this point, I started introducing it to your first general reaction. That's alkane or cycloalkane, oxygen, you got CO2 and water. Next chapter I talked about were the alkenes and alkynes. Alkenes, double bond, and alkynes, triple bond. Double bond you show by 2 lines between 2 carbons, triple bond 3 lines. And I taught you for a double bond that consists of 1 pi bond and 1 sigma bond. For a triple bond, 2 pi bonds, 1 sigma bond. Now here this is somewhat wrong. Double bond, drop the A and the ending of the longest chain that contains both carbons of the double bond and replace it with ENE. You need a number for acyclic, plus you have to consider cis and trans. ENE ending, no number for cyclic. And in a ring, one of the carbons of the double bond is always 1 when there's no other functional groups, which is true for my class this semester, and the other is 2. And let's take a look. If we look on the whiteboard, both of these have double bonds. The longest chain, and I'm now showing bond angles called stereochemistry, is 4 carbons, 1, 2, 3, 4. Even though they're bent, they're still connected together. And what you have, 4 carbons, butane, but there's a double bond, drop the A and E, put ENE. Is what's the lead carbon close to the end? 2-butene. Same thing here, 2-butene. But notice, and it's true for this class, each carbon of the double bond has a hydrogen. In this case, they're opposite the plane I just did, orthogonal with the dotted line, and opposite is trans. And in this case, they're on the same side of that dotted line or plane, and that's cis. And here's one for you to do. And what is the IUPAC name for that molecule? Oops, sorry about that. I see a couple of thumbs coming up. I'll give you a little more time. All right, let's do this. What do you see that's different? Double bond. What's the lead carbon double bond close to the end of the chain? Common mistake, people want to make that one. No, this is 1, 2, 3. If you went the other way, it'd be 1, 2, 3, 4, 5. So how many carbons total in the chain? Let's count. 4, 5, 6, 7, 8. That's octane. It's a double bond. Drop the ANE ending, put ENE. The double bond is 3. Notice the hydrogens are on the same side, so that's cis. And we have our old friend, the methyl group, on carbon 6. So that'd be 6-methyl cis 3-octene. And that's how you do double bonds. Now, if it's in a ring, you don't use a number, and we've gone through that in the past. Wrong place to go, right place to go. Now, for a triple bond, you find the longest chain. You can't have a triple bond in a ring, at least for this class. I've only seen it once, I think decades ago. I shouldn't have said that, but it's true. And you drop the ANE ending and replace it with YNE, have a number, there's no sister trans. Now we got into the good stuff, and that is reactions. And I started teaching you general reactions and how to apply them. You have a double bond, you add hydrogen and catalyst, you break the pi bond, each carbon gets a hydrogen. And the catalyst can be nickel, platinum, or palladium. If you take a double bond, and I taught you at this point, we use X for the halogens for this reaction, fluorine, chlorine, bromine, or iodine, to break the pi bond, and each carbon gets a halogen. And all the other carbons come along for the ride because you do not break carbon-carbon single bonds. Next, the first two are symmetrical. What happens when it's unsymmetrical? And the first one I taught you was this. You have a double bond react HX, where X can be chlorine, bromine, or iodine. One carbon double bond gets H, the other gets X, and it follows Markov-Nikov's rule. And Markov-Nikov's rule is the carbon with the most hydrogens of the double bond gets the hydrogen, the other one gets the halogen. And here's one for you to try. Draw the structure for the following reaction. And when you're done, give me a thumbs up. I'm glad they don't have thumbs down. Actually, it'd be fun. All right, I'm seeing a lot of people done. So I better get to work. And the question is, give the organic product or products for the following reaction. Look for what's different. Ooh, a double bond. Reacting with HI, well, iodine is a halogen. Remember, X can be chlorine, bromine, or iodine. And you break the pi bond, one carbon gets H, one gets X, the halogen, and it follows Markov-Nikov's rule. The carbon double bond with the most hydrogens gets the hydrogen, the other gets the halogen. If we look at double bond, this has 1, this has 0, and therefore the hydrogen will go there, and the other carbon will get the halogen. Do you break carbon-carbon single bonds? No. So the halogen is iodine. I know there are 4 bonds to carbon, so I can put in my hydrogens. And that's how you do it. Now, another reaction was double bond with acid catalyst. H plus is an acid catalyst, and water. Remember, water is HOH. You break the pi bond, one carbon gets H, the other gets OH, and it follows Markovnikov's rule. And how do we do that? Well, let's try one. And what would be the product or products of the following reaction? And I'm starting to see thumbs up all over the place. Give you a couple, another 20.5 seconds. All right, let's take a look at this. What's different? Ooh, a double bond and a ring, but still a double bond. I'm adding acid and water. And you break the pi bond, and one carbon gets H, the other gets OH. And this also follows Markovnikov's rule. The carbon of the double bond with the most hydrogens gets the hydrogen, the other gets the hydroxyl group. Or as my instructor, I still remember long ago, used to say, the rich get richer and the poor get poorer, but we're talking about hydrogen. Uh-oh, I don't see any hydrogens on that ring, but remember, there's 4 bonds to carbon, and we have our 2 carbons. This one down here has 3. 4 minus 3 means it has 1 hydrogen. This one has 4 bonds to it, means it has 0. Which is the greater number? Hopefully all picked 1. Wasn't the math hard in this class this semester? And therefore, I'm going to break the pi bond. The hydrogen will go here, but we don't show it. The hydroxyl group will go here. Now, if you put the hydroxyl group where the ethyl is and the ethyl group where the hydroxyl, that's okay too. Next, we talked about triple bonds. And triple bonds, you have 2 pi bonds, and when you break it, you need extra hydrogen, but organic chemists are lazy, and we have the term bracket excess, or the symbol close bracket, meaning you have excess hydrogen. You have all the hydrogen in the world that will react with anything hydrogen can react with. And with 2 pi bonds, each carbon gets 2 hydrogens, and there's the product. For halogenation, same thing. We use the shorthand excess for excess, meaning you have all the halogen gas that can react with, in this case, 2 pi bonds. And because of that, each carbon of the triple bond gets 2 halogens. Now, next, I talked about aromatic compounds, and these are compounds originally isolated from spices and herbs, and they all have something in common, benzene ring. And a benzene ring is a cyclohexane ring, not really, a six-membered ring with three double bonds, or you can have the circle showing the conjugated double bonds of the ring. And this is benzene. When you have a methyl group on it, we don't call that methylbenzene. It has an ancient name that IUPAC said, well, we're going to keep it, and they call it toluene. Now, when it's disubstituted, we use the term ortho for 1,2 disubstituted, meta for 1,3, and para for 1,4. And I taught you now new substituents. Cl is called chloro group. F fluorine is called fluoro. Br bromo, iodine, iodo, and NO2 nitro. And I didn't do it for the alkenes. Why don't you do this one? Do it quick. Benzene. Draw the structure for benzene. All right, I think everybody's done. There are three ways you could do it. This is one. You can draw another what's called resonance form, or you could show the delocalized pi cloud. I like the first two because I think it's cool. Why did I put this down? Because if you do this, I'm going to mark it wrong. That's cyclohexane. Don't forget to either put the bonds inside a benzene ring or the circle, because otherwise it's cyclohexane and it's wrong. And what would be the IUPAC name for that molecule? Well, I see one thumb up. Oh, there goes a bunch more. I'll wait a little while, try and give everybody. That's the one bad thing when you don't have everybody have their web camera on, because in a face-to-face, I can look at the students and see when they're done or not. And they give me that look like, get to work, Dr. White. I've seen that look, so I know it. All right, let's get to work. What do we have here? Cyclohexane? No, benzene ring, but it has a methyl group. That's toluene. Now, toluene is considered disubstituted. Methyl group is 1. And on carbon 3, we have a nitro group. Notice this is 1,3 disubstitute, which is meta. So that would be meta nitrotoluene. And know how to draw a structure. Oh, let's do one. Why don't you draw the structure of para-T-butyl or tert-butyl chlorobenzene? All right, I think everybody's done. So let me get to work. You start from the right, move left. Benzene ring. Remember, this is cyclohexane. This is now benzene. I have a T-butyl and a chloro. Pair means 1, 4. Most of you probably put the T-butyl on top. Doesn't matter. One, two, three, four, and there's my chloro. And you could have them switch the chlorine on the top, T-butyl on the bottom. Now, with a benzene ring, you do not break the double bonds in the ring because there's resonance stability and you don't want to, and Mother Nature doesn't want you to lose that stability. So when we have halogen, X2, because it's a benzene ring, you need a catalyst, ferric trihalide. I've only seen this done with chlorine and bromine. You replace one of the hydrogens with a halogen. Now, since I did not teach you in the classroom about directors, those are the only two reactions I can give you. Next, if you take benzene ring and react it with nitric acid and sulfuric, you make the nitronium ion, which you saw in the lab, and you put a nitro group. Remember, it's not NO3, it's NO2. And next, if you take sulfur trioxide, and by the way, with the nitric acid and sulfuric, since I'm not doing directors, this is the only reaction I can ask on the final. Next, if you have sulfur trioxide and sulfuric acid, you react it, you put a sulfonic acid in, don't forget the hydrogen here. And finally, this is the first time I showed you, and they're very rare, how to make a carbon-carbon single bond. And this is Friedel-Crafts alkylation, but it's time for a cliffhanger. You're going to have to wait until after the break. Let's take a 5-minute break. I'm going to go stretch, and I'll see you at 1:55. Let's try that again. Time to start again with my mic on. All right, we're talking about aromatic compounds and reactions. And the last one for this chapter, which I taught you, was, and this is test one material, Friedel-Crafts alkylation. And here you react an alkyl halide with aluminum trihalide, and X can be chlorine and bromine, and the carbon with the halogen will replace one of the hydrogens as now bonded to the benzene ring. And what would be the organic product or products for the following reaction?
Dr. White, your whiteboard didn't come on.
What?
I don't see the whiteboard.
Uh-oh. Now do you see it? Thank you very much, Matt. That happens with Zoom every once in a while. I clicked on it, it should have switched over, it didn't. Anybody know anybody at Zoom? I'd like to talk to them about some improvements they could make. And when you're done, give me a thumbs up. Oh, the thumbs are starting to come up. All right, is everybody done? Let's do it. I'll give you another 10.8 seconds. All right, let's take a look at what's different. Ooh, a benzene ring, that's different. What about this molecule, carbon? Ooh, a halogen, that's an alkyl halide. In this case, and I taught you about R being like X and Y in math, an alkyl halide, and we have aluminum trihalide. X can be, for this reaction, bromine or chlorine. Most likely it's going to be chlorine, and you replace one of the hydrogen with the R group. The carbon with the halogen will be the carbon bonded to the benzene ring. Don't forget the lines or circle inside the benzene ring, otherwise that's cyclohexane and it's wrong. And I have 3 carbons. Notice the center carbon is got the halogen. That's the one that will be bonded to the benzene ring. And there you go. And that's everything from test number 1 material. Let's proceed to test number 2. Don't forget, these reviews are in the lecture folder of D2L. Next, I start talking about alcohols. And alcohols are compounds with a hydroxyl group on a carbon. Remember, hydroxyl group is not a functional group, but it's just our way of talking about oxygen, hydrogen together. And for an alcohol, for acyclic, you find the longest chain, and then you drop the E with the carbon hydroxyl group on it, drop the E, add OL, and a number. That number is always the lowest carbon to nearest the end of a chain. And then if there's a ring, you have no number, because the carbon with the hydroxyl group in a ring, when there are no other functional group, which is true for my class, always, I've kept it that way, number 1. Now, 1, I taught you there was a special name, benzene ring with a hydroxyl. I pronounce it phenol. No, it's not phenol, even though most chemists do. It's wrong. I'm right. But anyways, you should know the structure. And then I talked about common names. And common name is you name the R group on the hydroxyl is attached to as an alkyl group, then add the word alcohol. Example, rubbing alcohol contains 70% isopropyl alcohol, 30% water. Or nowadays, you can get this up to 90% isopropyl alcohol. And you should know for my tests, or final now, that was true on the test, I will never give you a structure and ask what's the common name in this chapter. Later on for amines I did, and quaternary ammonium salts, but I will give you the name and ask you to draw it. Now, how do you make an alcohol? Well, we've already done this reaction from test number 1, and it was in test number 2. Now, reactions to the alcohol, probably the most challenging, one of the more challenging is dehydration. Take an alcohol where it has a carbon adjacent to it, a hydrogen, reacted with sulfuric acid and heat, H2SO4. You can either see the triangle or the word heat, and you lose HOH, water. And between those two carbons, you form a double bond. Now, this follows Zayseth's rule. And Zayseth's rule is you get the double bond, the alkene, that has the most carbon atoms directly bonded to the carbons of the double bond. I'll say that again. Zayseth's rule is you get the alkene, the double bond, that has the most carbon atoms directly bonded to the carbon of the double bond. And therefore, I'm going to give you one to have fun with. Now, I may write heat, or I could use a triangle. I forgot which I would do, but I can do either one. And the question is, what's the main or the product you get for that reaction? Your turn. Remember, Zayseth's rule is you get the alkene that has the most carbon atoms directly bonded to it. All right, looks like just about everybody's done. I'll give you another 15 seconds. I'm in a generous mood today. All right, let's do it. What do we see that's different? Hydroxyl group on a carbon. We're reacting with sulfuric acid and heat. And so I have an adjacent carbon with a hydrogen. I form a double bond and it follows Zays's rule. And that is the carbon with the double bond you get has the most carbon atoms attached directly to it. So if I go to Technicolor, what are the adjacent carbons? A and B. If I lose the hydrogen from B in the hydroxyl group, I will get, well, let's do A. If I lose the hydrogen from A in the hydroxyl group, I'll form a double bond and the rest of the molecule still comes along for the ride. Now, if I lose the hydrogen from B in the hydroxyl group between these two carbons, I'll form a double bond. Now, to find out which is the product you get, I need to do Zays's rule. How many carbon atoms are directly bonded to the carbons of the double bond? In A, it's 1. In B, it's 1, 2, 3. Which is the larger number? Time's up. Hopefully all picked 3. Therefore, this is your answer. And that's how you do Zays's rule. Now, I'll never give you a synthesis problem on that. There will be some synthesis problems on the final exam, just like the hourly, but not a lot because that'd be cruel, unusual punishment, which is still to this day, I believe, outlawed by the Supreme Court. All right, next reaction. Alcohol reacted with HX. You replace the hydroxyl group OH with the halogen on the carbon the hydroxyl group has. Since this might react with a double bond, even though I won't give you that in this class, someone came up with take an alcohol, react with thionyl chloride, SOCl2, and you replace the hydroxyl group with the chlorine. Now, next I talked about oxidations. And oxidation are where certain chemical, it's called oxidized alcohols. Instead of asking you to learn the oxidation reagents, structures, like I did for catalysts, nickel, platinum, and palladium, organic chemists use bracket O, close bracket, meaning oxidation. If you have a primary alcohol, use the hydrogen from the carbon with the hydroxyl group, the hydrogen from the hydroxyl group, and form an aldehyde, which you didn't know that, the name of this, but that's what you form. If you oxidize a secondary alcohol and you lose the same thing, hydrogen from the carbon with the hydroxyl, hydrogen from the hydroxyl, OH group, and you form a carbon-oxygen double bond, and you make a ketone. Tertiary alcohols do not react, as you saw in the lab. But I will never, ever put on a test of mine or final or question, give the organic product or products where the correct answer, because it will never be correct, is no reaction. If I ask you, give a product, it's going to react. Now, next we start talking about thiols. And the only thing I asked you to know about thiols are they stink, and that thiols are put in natural gas so you can smell it if you have a natural gas leak. And I talked about that tragedy in Texas, and I think it was circa 1935. Very, very sad when the school blew up from a gas leak. And over 100, and I think 50 students and teachers were killed, and many others were severely burnt and injured. All right, but thiols, RSH, are put in natural gas so you can smell that. They stink. Next, I talked about ethers. And ethers, R-O-R prime, is an ether. Now, good news, nobody uses IUPAC for most ethers. So I only asked you to learn the common name, and that is name each R group as an alkyl group it is, and then add the word ether. Now, there's only one reaction because ethers really, you don't react them. They're used as solvents in reactions. But to make an ether, the best way is the Williamson ether synthesis. Take an alkoxide plus an alkyl halide, and you make an ether plus salt. And if I'm asking you a synthesis problem, I'll include the salt, which I did in test number 2. Oops. Oh, come on. There we go. And give the organic product or products are the following. And I see some thumbs up, so I'm gonna get to work. What's different? Ooh, oxygen and minus charge sodium cation, R group alkoxide. Carbon, ooh, a halogen on a carbon, alkyl halide. And this is how you make an ether. Remember, the carbon with the halogen is what the oxygen will be bonded to in your ether. This is my R group. This is my R prime. You don't break carbon-carbon single bonds, so I have 4. Remember, this carbon is the carbon with the halogen. It will bond to the oxygen. Then the R group is this. And this is the product you get. Why did I show this? Because on test 2, a common mistake, let me do something. I'll do it in red so you know it's wrong. People wrote this. And this is wrong. No. Immediately, if you look at this carbon, it has 5 bonds to it. No. If you look at this one, it has 3. No, this group goes here, not on that carbon. Be careful where you place things. And when you do, count bonds. Make sure there are 4 bonds to carbon, because I don't like taking points off for, you sort of knew what it was, but you didn't know. Next, we talked about ethylene oxide epoxides, and there are two reactions I showed you. Take an alcohol, react with ethylene oxide, you get this ether alcohol. If you, with 1 mole or molecule of ethylene oxide, if you have N moles of ethylene oxide, you get this polyether alcohol. Common mistakes, students put the hydroxyl group inside the parentheses. No, and N comes from the coefficient here. Your turn. Give the organic product or products for the following. Well, I saw one thumbs up. Oh, they're all starting to pop up now, like popcorn. All right, let's take a look at this reaction. What's different? Remember, look for what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Ooh, oxygen with a hydrogen on a carbon, alcohol. Ooh, 7, that's inched, I'll call it N. And this is ethylene oxide. And the product is this polyether, if I can write it correctly, alcohol. And remember, the hydroxyl group goes outside the bracket. What's our this? Then I have my bracket OCH2, CH2, close bracket, what's N? The coefficient from 7, and that's how you do it. And these are very useful compounds used in our daily life. They're called surfactants, and they're used in many things, and we talked about it back then. Now, next, we got to talk about one of my favorite areas of organic chemistry, and that's aldehydes and ketones. And an aldehyde and ketone, aldehyde, carbon double bond to oxygen with a hydrogen R group, ketone, carbon double bond to oxygen with 2 R groups. Now, for nomenclature, for an aldehyde, find the longest chain with the carbon double bond to oxygen, which somewhere down here I should have. Carbonyl group. Remember, this is one of the more important things to me in all of organic chemistry personally, and I think it's true for other organic chemists. Carbonyl group, carbon double bond to oxygen. You should know how to describe it in words and draw it. Oh, I even put my symbol for important there. And test 2, I asked you, what is a carbonyl group? Now, for an aldehyde, you find the longest chain with the carbonyl carbon, name it as an alkane, drop the E, add Al. No number because the carbonyl carbon is always number 1. And you name the rest of the alkyl groups like you always have. Now, when R is a benzene ring, we call that benzaldehyde, and that is both the IUPAC and common name. You can't have an aldehyde in a ring, so we don't have to consider that. Now, for a ketone, you find the longest chain that has the carbonyl carbon, or you can have it in a ring. If it's acyclic, you name it as an alkane, drop the E, add ONE, and you need a number. What number that carbonyl carbon is closest to what end of the chain? If it's cyclic, no number, because that carbon is always going to be number 1. And let's have a little fun. Remember, there are 2 types of nomenclature question. One is, here's the structure, give the IUPAC name. The other is, here's the name, draw the structure. And why don't you do that? Draw the structure 2,3-dimethyl 4-isopropyl cyclohexanone. Enjoy. Ah, but it is a fireman's hat. Looks cool. But then the little boy in me always had a special place in my heart for firemen, more than policemen, because they had cooler stuff to climb over when I was a kid. All right, let's do this. How do you draw this? You start from the right, move left. ONE ending, ketone. That were an E, cyclohexane. Carbonyl, that's cyclohexane. On carbon 2 and 3 is 2 methyls, carbon 4 isopropyl. This is 1, 2, 3, 4 isopropyl. My 2 methyl groups. And I'm smiling because that's a pretty molecule. Now you know I'm an organic chemist. Now, there are 2 common names I asked you to learn. One was formaldehyde. That's the simplest aldehyde when R is a hydrogen. And then acetone, that's the simplest ketone when R and R prime are both methyls. Nobody ever calls them by their IUPAC, methanal, or 2-propanone. They call it formaldehyde and acetone. At this point, won't be on the final. I talked about the dangers of formaldehyde, especially buying wood products from China. Be careful. And as long as it's not solid wood, particle board, or something like that, be careful. And time for an important message from me. And that is, If you ever have any questions about anything I've talked about this semester, including safety or anything else, like formaldehyde, if you have questions about that, or the other things which are not as serious but important, like how to clean a bathtub or how to clear out a stop drain. In other words, using uh, the best drain cleaner, that hair and grease remover, always feel free to email me. You don't have to be in my class. Since you were in my class, I always help former students any way I can. Now, I just went through what's one way to make aldehydes and ketones. Oxidize a primary alcohol, you get a aldehyde. Oxidize a secondary alcohol, you get a ketone. And since I just went through it, I can do the following. What would you oxidize to make that molecule? And when you're done, give me a thumbs up. All right. I see thumbs have popped up. So how do you do this? Synthesis. One product, so starting material, oxidize. What's different here? Ooh, carbonyl. But not just a carbonyl, an aldehyde. And what do you oxidize to make an aldehyde? A primary alcohol. And what's our isopropyl? Remember, use common sense, but as one of the best mentors I ever had used to beat in my head, common sense is not common. You end up with 4 carbons. I didn't add any. I better start with 4 carbons. 1, 2, 3. That's my R group. Then CH2OH. And there's 4 bonds to carbon, so I know how to put in the hydrogens. And I did. And if you oxidize that, you'll get that aldehyde. Now, there was a really nice reaction I showed you to make aromatic ketones. That's Friedel-Crafts acylation. Acyl group is R carbonyl. This is an acid chloride. You react that, you make a aromatic ketone where one of the R groups is a benzene ring. Well, it can be other things, but I kept it simple for this class. And I had that on test 2. Now, next 4 reactions are challenging, but you people mastered them. And I will never give a synthesis problem on the next 4 reactions. First one, take an aldehyde or ketone. When R prime is H, it's an aldehyde. When it's carbons, it's a ketone. React it with an alcohol and acid, you get a hemiacetal. The carbonyl carbon is this carbon. It opens up to have a hydroxy group and OR, and the R comes from the alcohol. what was attached to the carbonyl carbon, R prime or H, and R double prime stays there. Next, I said if you take an aldehyde or ketone, now react not one, but two molecules in alcohol and acid catalyst, excuse me, you make a acetal or ketal. And here you replace the carbonyl with two oxygens. Each one has an R group. I talked about a special case that my advisor's advisor discovered or created, which was putting a protecting group on an aldehyde or ketone by reacting it with ethylene glycol. Notice this is two alcohols, and you get this cyclic ketal or acetal. As I stated, students forget to put the bond between the two carbons. Please don't. Now, once you make them, if you react it with acid and water, you get back the aldehyde or ketone you would have used plus the alcohol from the hemiacetal, hemiketal. As I taught you later, this in the next reaction is how your stomach breaks down carbohydrates. And if you start from a acetal or ketal, I don't have it here, but R prime can be hydrogen. I have it on this side. What's attached to the carbonyl, you get back as a ketone or aldehyde, and the 2OR on the acetal ketal forms an alcohol. And for those who feel they have to balance it, you can put a 2 there. I wouldn't. Those reactions, I will never give a synthesis on a final or the test number 2. And I didn't. Now we had some fun stuff. You take an alkyl halide reactor with magnesium, you get a Grignard. Remember, for a Grignard, X can be chlorine, bromine, or iodine. And this is important. The magnesium is bonded to carbon, the halogen to the magnesium, not the other way around. Oh, let's have some fun with this. I need a fun time. Have some fun. Ah. All right. Did I miss any thumbs up? Oh, they're starting to come up now. Anybody need more time? Oh, I know what I can do. Well, looks like just about everybody's done, so let's get going. What's different? Look for what's not a carbon single bond, or carbon or hydrogen, halogen on a carbon, and that's an alkyl halide. Ooh, magnesium. And we form the Grignard reagent. Number X here can be chlorine, bromine, or iodine. And now, what do you get? Here, this is R. You don't break carbon-carbon single bonds. And then the carbon with the halogen will be bonded to magnesium, and then the halogen, in this case chlorine, that's what you get. Now that you got a Grignard reagent, what can you do with it? Have lots of fun. And this is one of those special reactions where you can make a carbon-carbon single bond. Here we have an aldehyde or ketone. Grignard's second step, that should be acid plus H2O. The O fell out somewhere. If you see it, let me know so I can replace. Oh, that was an awful joke. But this on the Grignard, R triple prime, attacks and bonds to the carbonyl carbon and opens it up to an alcohol. And for some reason, students have trouble this reaction. So let's have some fun. And here's something to have fun with. Give the organic product or products to the following. And this reaction, I will never give a synthesis problem on. So that also would be cruel, unusual punishment, which we're not allowed to do. All right, I think everybody's done. Let's take a look at this. What's there? Ooh, an oxygen double bond to carbon with carbons here and here. That's a ketone. But it could have been an aldehyde, but it's not. What's different here? Carbon, ooh, magnesium halide. We have a Grignard. Second step, acid and water. Number X here can be chlorine, bromine, or iodine. This attacks that, opens it up, and what do you get? You get something very special, very unique. You make a carbon-carbon single bond to the carbonyl carbon. This opens up to an alcohol. Now, what's our and R prime? This is our double prime and R prime is the ring, and therefore it's still going to be there. The carbonyl carbon, this carbon, which is this carbon, what's the R triple prime? Ethyl. And this will be also an alcohol. And that's how you have it. Now, if you have the hydroxyl on top and the ethyl group on the side, that's fine. And that's how you do it. Now, if you have a carbonyl carbon, you have a carbon oxygen double bond. That's one pi bond, one sigma, just like a carbon double bond. And if you react the ketone or aldehyde with hydrogen, a catalyst can be nickel, platinum, or palladium. Guess what? you break the pi bond, and each atom of the double bond gets a hydrogen. You make an alcohol. Now, hydrogen, if you had, you won't have in my class, but if you did, and I showed you, could react with double bonds in our prime or our double prime. So you don't want to use it for that. And a great organic chemist, H.C. Brown, Dr. Brown from Purdue, came up with lithium aluminum hydride, LiAlH4. And if you use that with an aldehyde or ketone, second step, acid and water, you break the pi bond, same thing. But lithium aluminum hydride will not react with double bonds, but I won't give you that. And finally, the last thing I talked about was the aldol condensation. And here, the alpha carbon, the carbon bonded to the carbonyl, has acidic protons. You can take it off and form an enolate anion, minus charge on that carbon. It attacks the other carbonyl carbon and forms a carbon-carbon single bond, and the structure is an aldol. And that's why it's called an aldol condensation. And my gift to you is I'll put both. In my level, we don't put anything other than one, and you know that's going to happen. And here's one for you to try. And I will tell you, sodium hydroxide, NaOH, and water will not react with a benzene ring. Have fun. Uh-oh, I see a thumb. I see another one. I think the thumbs are coming up. I'll give you a little more time. All right, I better get to work. What do we have here? Ooh, an aldehyde, but I'll write it this way. Same aldehyde. And what are we reacting it with? Base sodium hydroxide and water. And the alpha carbon forms an enolate, attacks that, and you get an aldol condensation. The alpha carbon of one aldehyde reacts with the carbonyl carbon of the other, opens it up to an alcohol. What was attached to it is still attached to it. And therefore, if we come up here, what's our? A benzene ring. So here's the alpha carbon. It will attack that carbonyl carbon. And what was attached to this carbon is still attached. Wow, that is a pretty molecule. And with that thought, I just lost my train. Oh, I forgot to mention something. Near the end of the semester, I try and keep up real close. If you go to D2L, the grade book, you should see the lab, if you handed it in, is in D2L. And also for those of you who handed in the extra credit project, that's there too. And with that, oh, I went a little longer than I should have this break. I got excited with an aldol condensation. They are exciting. Let's take a 5-minute break, come back at 2:53. I'll make it 2:55. I'm gonna give you an extra 2 minutes. I'm generous today. I'll see you at 2:55 and I'll be back. Hopefully you will too. I was checking the internet. It's time to start again. I haven't used this in a while. Time to go. All right, let's continue. And if you notice, we finished everything for test 2 material. Let's move on to test number 3. The first thing I started talking about, and let me just check. I'm glad I checked. Everybody, do you see test 3 review now on your screen? I hope you do. Thank you. Thumbs up, people. My morning class, I think they don't like using thumbs up. They're so slow. But anyways, carboxylic acid, carbonyl with a hydrox group and an R group. How do you name it? Find the longest chain with the carbonyl carbon, name it as an alkane. Drop the E, add OIC in the word acid. Carbonyl carbon is always carbon number 1. Now, let's give you one to try. All right, give the IUPAC name for that molecule. Oh, the thumbs are popping up all over the place. And for those who are quicker, I try and give everybody, to all people, time to finish. All right, let's do it. What's different? Ooh, oxygen here, oxygen double bond here. This is a carboxylic acid. And how do you name it? You find the longest chain with the carbonyl carbon, 1, 2, 3, 4, 5, 6. Name it as an alkane, hexane. Drop the E, add OIC, and the word acid, hexanoic acid. The carbonyl carbon is 1, 2, you don't put a 1 though, because everybody knows that, 3, 4, 5. So we have 2-ethyl, 5-methyl, hexanoic acid. You put the 5-methyl first and the 2-ethyl second, I'll give you credit, even though the IUPAC police would arrest me. No, there's no IUPAC police. Now, common names. There are a couple I asked. One, when R is a methyl, that's acetic acid. And you should know that's the name. When R is hydrogen formic acid, now, both the common and IUPAC, when R is a benzene ring, it's called benzoic acid. Now, acetic acid, you mix it with water, small amount, 4% acetic acid, 96% water, and you get vinegar. And when I asked name a product that has a carboxylic acid in it and other things, yes, I did on test number 3. Hint, hint. Now, carboxylic acids are acids because they're proton donors. And the acidic proton is the hydrogen on the oxygen of the carboxylic acid. And for this class, you react it with a hydroxide base, MOH, where M is lithium, sodium, or potassium, you get this carboxylate anion. And I forgot to do something when I can correct it right now. I don't think I talked about this, but let's do one first. What would be the product or product for the following? R is 16 carbons, also known as palmitic or P. That'd be palmitic acid, which is the common name of a fatty acid. All right, let's do this. What do we have here? Carboxylic acid. Ooh, base and water. M can be lithium, potassium, or sodium. And you get a carboxylate anion. In this case, you'll get this carboxylate like this. Now, I taught you later on in soaps, when you have a surfactant, when this is very long, which it is. Now, I don't know if I mentioned this, but I'll talk about it now. I thought about it. And that is, I actually met from a company I worked at. He was close to retirement, or actually it was more than one person. That is, in World War II, the Air Force, I think, or the Army, I forgot which, probably the Air Force, was looking for a weapon to help destroy the enemy. And they wanted something that would burn them. Yes, it's war, and war is not polite. And they came to a company I later on worked for, because that company was experts in surfactants. They wanted to know, how can we mix oil and gasoline together? And one of the ways was to use the molecule you just made. And that's called sodium palmitate. And the company, the guy who came up with it, the group, one of the people, they were looking for a name for this new product, said, well, it's sodium. It's made from palmitic acid. Let's call the whole product gasoline, water, and this sodium carboxylate anion napalm. And that's the story behind napalm. I'm not sure if I told it to you before, but now I have. Organic chemistry can be used for positive or good things and things that, well, in war, you need things to defeat your enemy. Now, I also talked about a special base, baking powder, sodium bicarbonate, carboxylic acid. You get the carboxylate anion plus water plus carbon dioxide is given off as a gas because you form carbonic acid which breaks down to water and CO2. And I talked about my little rocket ship that my father taught me how to take vinegar and react it with sodium bicarbonate. So let me really test you. If you react vinegar with sodium bicarbonate, what are all the products you get? And by the way, if you make bubbles, which you might see are gas, what's the gas? I see one person done. Oh, then there were two. And it looks like everybody's done. Let's do it. What's vinegar? And you should know this. It's acetic acid. And what I'm really asking is this reaction. And the general reaction is carboxylic acid plus sodium bicarbonate gives a carboxylate anion plus water plus CO2 given off as a gas. So what's our methyl? And therefore you get, and I didn't ask you to learn this, sodium acetate, which is the common name of this carboxylate anion, plus water plus CO2, and the gas is carbon dioxide. And I told you the story about the little rocket ship and how my father taught me how to do that. Now, how do you make a carboxylic acid? You take an alcohol and react it, oxidize it, you'll get a carboxylic acid. Now you're saying, wait a second, what if you put that on the test? You get the aldehyde or acid? And the answer is, if you put either one, I'll mark it correct. Now, if you take an aldehyde and oxidize it, then you get a carboxylic acid. Now, my favorite one, because it's really cool, and it is, take a Grignard carbon dioxide, second step, acid and water, you get a carboxylic acid, one carbon longer than the carboxylic acid you started with. Because the Grignard attacks the carbon of CO2, which looks like a carbonyl carbon, like in a ketone or aldehyde. Next, I talked about esters. And esters are carbonyl with oxygen with carbons on it, R prime. Carbonyl has R on it. We call that an ester. Oh, by the way, I'm not doing it now, but do I have everybody's attention? Ooh, I can get your attention. I got your attention now. Be sure you check and play that fun game, circle and name the functional group, 2 points each. That's one thing. The other thing I mentioned before, but I better mention now before I forget, and that is on the final, I will have material from test 1 first. Then I'll have test 2 material, test 3, test 4, and then amino acids and protein material will be at the very end. So that way you might, I've made it maybe just a little bit easier for you. I'm not playing 52, shuffle the deck with all the different questions. Test 1, 2, 3, 4, and then proteins and amino acids. All right, now how do you name esters? Well, you name the R prime in the front as an alkyl group. Now, there are 2 ways of naming the rest of it. The IUPAC way is 2A, and that would be name the carboxylic acid think of R prime as H that's used to make the ester, drop the IC in the word acid, and add OATE. Now, the other way, which a very inventive Chem 170 student, for everything when R is not benzene ring, name the alkane from the chain with the carbonyl carbon, the longest chain, drop the E, and now add OATE. And I will never put an alkyl group on the R group. That makes your life too complex. And let's try something. And what would be the IUPAC name for the following molecule? Don't forget, one of the bad habits of mine is I like drawing structures before I write words. So when we do a nomenclature, sometimes I'm more structure heavy than here's the name, draw the structure, but make sure you practice both. And make sure you got the lab we did yesterday in by at the latest Thursday, because it's the end of the semester. Don't be late. All right, I think everybody's done, but I'll give you a little more time. All right, let's take a look at this. What do we have that's different? Oxygen here and here to a carbon. Ooh, a carbonyl carbon. Oxygen with carbons on it and carbons on the carbonyl. And we have an ester. What's our prime? T-butyl. Put that in front. Then I have 1, 2, 3 carbons. Since that's not a benzene ring, I can use propane. Drop the E, add OATE, and that's T-butyl propanoate. Now let's see if I put it in or not in the review. I did. And carboxylate anions are the same almost as esters. Name M plus as the element it comes from, like sodium, potassium, or lithium. I'm going to stick to those alkali metals, and then use ester 2A or 2B, or not 2B. I can't resist that. Now, you should know esters are responsible for the smell of flowers and the smell and taste of many vegetables and fruits. Now, how do you make an ester? The Williamson ether synthesis. Take a carboxylic acid and alcohol, acid catalyst, and you get an ester. And here's one for you to try. Give the organic product or products to the following. Excuse me. And the thumbs are starting to pop up. Okay, I think everybody's done. How do we do this? We look at two starting materials. What's different? Benzene ring, that's not going to react with this and an acid catalyst, but I have a carboxylic acid. And my benzene ring is this R. Carbon, carbon, carbon. Oh, hydroxyl group, alcohol. And acid catalyst. And what you get is an ester. What's R prime? Isopropyl. So I have my benzene ring. Don't forget to put the lines inside. Otherwise, that's cyclohexane ring. I mark it wrong. Carbonyl, oxygen. What carbon has the hydroxyl group? Is the carbon bond to the R prime in my ethyl, and that's the end one of 3. Oh, this is fun. We got to do another one. What two things do we react with acid to make that compound? Remember, these reactions are the building blocks that, or the tools that organic chemists use to make all the molecules we use in our daily life. And when you're done, give me a thumbs up. It's time for the bad joke of the afternoon. And thumbs up are starting to pop up, just like when you're popping popcorn and the first kernel or two goes, then all of a sudden never all of them go. Well, it's time for me to get started. I said bad joke or analogy. All right, what's different in the product? Uh-oh, I think my hang in there, I got to reboot and set. Yep, let me do something. All right, hang in there. Yeah, I think I lost my ester. So Let's see how good my memory was. If it's not the exact ester, well, this was similar. All right, we should be back on track. And the question was an ester. And what do you have, an ester? And what do you react with an ester? Or what do you react to make an ester? A carboxylic acid plus an alcohol. And therefore, this is R prime, this is R, and I have this carboxylic acid plus this alcohol. And that's how you make esters. And next time you smell perfume, don't forget that's a very complex mixture of esters mainly. All right, now that you have an ester, what can you do with it? You take an ester and react it with acid and water, you get back the carboxylic acid plus the alcohol you would have used to make that ester. And let's try one. And this reaction I taught you later on was how your body breaks down fats and oils, which are triester triglycerides. What would be the product or product? And on the test, I would do this to indicate, or the final, that they're two products. At least I try to. Once in a while, forget it. All right, let's check. I think everybody's done, so I better get to work. What's different? And really, when I look at a molecule, immediately I see this oxygen, this one to same carbon, carbonyl, oxygen. On this oxygen, I have carbons. On the carbonyl carbon, I have carbons, ester. Acid and water, you get back the carboxylic acid you would have used to make that ester plus the alcohol. And here, this is my R group. This is my R prime. Therefore, I get this carboxylic acid. Remember, you do not break carbon-carbon single bonds. And my R prime is this alcohol. Now, when you do the same reaction, base hydrolysis of an ester, also known as saponification, you don't get the carboxylic acid, you get the carboxylate anion of the carboxylic acid you would have used to make that ester plus the alcohol. Why? Because the carboxylic acid, as I showed you earlier, if I can find it, reacts with any base immediately to form the carboxylate anion. And the fastest reactions in all of chemistry are acid-base reactions. And let's move on. Next, I started talking about amines and amino derivatives. There's primary, secondary, tertiary amines. Remember, nitrogen has 3 bonds to it, or it could have 4. Unlike carbon, which has 4 bonds to it, nitrogen could have 3 or 4. And being the person who's worked with amines and their derivatives, nobody uses IUPAC names. They use common names. So for this, unlike, excuse me, the other sections in the nomenclature question, you could give the IUPAC or the common name. How do you do an amine? You name the alkyl groups on there, and at the end you add the word amine. There's one special amine I asked you to learn, and that's aniline. Aniline, when you have an NH2 group on a benzene ring, this is important, an amine. Why? Because it's used to make dyes. Like anything you wear, if it's not white, it's used, aniline was used to make the dye, to give it that color. Now, when you have 4 groups on nitrogen and an anion, because now you have nitrogen is a plus charge cation, and you need all molecules have a net 0 charge, so you have an anion, and this is called a quaternary ammonium salt, which is very near and dear to my heart, especially since I have a whole bunch of patents in quaternary ammonium salts. And how do you name a quaternary ammonium salt? You name each R group as the alkyl group it is, and at the end you put ammonium halide. For chloride anion, chloride. For Br minus, bromide. I minus, iodide. Now, R prime, our double prime, our triple prime, our carbons in a quaternary ammonium salt, we have something called an amine salt. An amine salt has 3 R groups that are 2 of R prime and R double prime can be hydrogen. And this you name the same way as a quaternary ammonium salt, except you don't have 4 R groups on it. And let me remind you, This would be dimethylamine, but organic chemists are lazy, so we'll normally write it this way. Both of these are dimethylamine. And that's unusual. We don't do that for carbon. I've never seen that done. But anyways, give the common name for the following molecule. And I think the thumbs are all up. So let's look at this. What's different? Ooh, a nitrogen. It's got a charge on it. And you have an anion. It has 4 groups. 2 plus 2 is 4. So this would be dimethyl, because it's a quaternary ammonium salt, diethyl, ammonium, and this tells me is chloride. And don't forget, quaternary ammonium salts are, not this one, but others are excellent fabric softeners. Some are, and some are antimicrobial compounds. And where do you find them? Like in fabric softener products, the dryer sheets, or the liquid. Dryer sheets work better. Or in things like, remember my mouthwash as an antimicrobial compound. How many of you have ever seen the spray that you can buy at big box stores that kills mildew and other yucky stuff? I like that for scientific yucky stuff. If you look at the label, that contains a quaternary ammonium salt. Now, how do you make a quaternary ammonium salt? If you take ammonia plus an alkyl halide and base, you'll get a primary amine. If you take a primary amine reacted with an alkyl halide, remember X is chlorine, bromine, or iodine, in the presence of base, you'll get a secondary amine. And if you have a tertiary amine, a secondary amine, I'm getting ahead of myself, reacted with an alkyl halide, you make a tertiary amine. Now, my favorite, because it helped pay my mortgage and a bunch of cars I bought, if you take a tertiary amine and react with an alkyl halide in the presence of base, you'll get a quaternary ammonium salt. And what would be the product or products of the following reaction? 3 points each. Sorry about that. I got up way too early this morning. I actually started work at about 5 o'clock. Okay, let's do it. What do we have here that's different? Oh, a nitrogen has 1, 2, 3 groups on it. Tertiary amine. What do we have here? Carbon halogen. We have an alkyl halide. Remember, X can be chlorine, bromine, or iodine. And you react that in the presence of base, and you get a quaternary ammonium salt. And here I can say these two are R and R prime. This is R double prime, and the methyl group is R triple prime. And the quaternary ammonium salt, one way to write it, I have my 2R sub T tallow group, nitrogen. And notice I'm going to add another methyl group. I already have one, so I can write it this way. And that'd be the way I would, but I'm running out of room, so I'm going to scoot down here. Well, I've never used that word, scoot. And another way of doing that, you could have written it this way. And you don't have to put the charges there, but I always will. And you make ditallow dimethyl ammonium chloride, which until about 10 years ago was the only molecule used in fabric softeners. You know something? We're on good track right now. Well, you don't know something because I haven't told you. First of all, I hope you found this review useful. I think you will come Thursday. If you don't forget, on Wednesday night, if you have any last minute questions, I'll have my office hours. But with that, I'm going to end a whole 60 seconds early. Shh, don't tell the dean. With that, thank you for showing up today. I hope this was helpful. Game gesund. Goodbye.